Hi, my name is Mike Schwarz and I'm the Managing Director of iTech Minerals. Today I'd like to give you some updates on our Caralue Bluff Kaolin and Rare Earth Element Prospect. In particular, I'd like to talk about our preliminary metallurgical results and then also update you on some of the kaolin test work that we have just received and how that kaolin test work plays into the rare earth element story at that prospect. So a few weeks ago we released the preliminary metallurgy from the Caralue Bluff Rare Earth Element and Kaolin prospect. That metallurgy was done on 19 holes of about 260 that we had drilled earlier this year. So it only covered about 7% of the material that we've tested so far, and only of those only 8 were within the exploration target that we have recently defined. That is for kaolin and rare earths. So from the results of that leaching, we got maximum recoveries of the magnet rare earths, which are neodymium, praseodymium, dysprosium and terbium. For neodymium and praseodymium, roughly about 30% recovery, and for dysprosium and terbium, we got better recoveries of 65 to 57%. So what that told us is that we have room for improvement in improving those recoveries, and we aim to do a second round of metallurgical test work now where we are varying those leaching conditions. So before we used just relatively low-key standard leaching conditions, now we're going to start varying those to see if we can get more of those magnet rare earths into solution. Now we believe that we have the opportunity to vary those leaching conditions and get more of those rare earths into solution, because what we're dealing with is a very high purity kaolin source material. That means it's low in impurities, so less of those impurities are likely to go into solution with slightly more aggressive leaching. And what that will also do is improve the quality of that kaolin material as a secondary product to the rare earths. So we recently got some of our kaolin test work back, and that is assessing the quality of the kaolin material that holds the rare earths and what that is likely to be as a product, say in ceramics as a source for high purity alumina, or in other technological applications of kaolinitic material. And we were very, very pleased with those kaolin test work results. What it showed us that is when we sieved out the fine material, which is dominated by kaolin, that's the minus 45 micron material, that we got really good recoveries of the almost pure kaolin in some cases, where it comes up to 37.6% aluminium oxide. Aluminium oxide is a measure of how much kaolinic material is there. And then we had low impurities, and the impurities generally consist of iron oxide or titanium, and they're impurities because they stain or colour the white kaolin material. So if they're low, close to zero, then that's all good. What is also important is that the calcium is low. Now, the reason that it's important that the calcium is low is that calcium consumes acid, or it neutralises it. So when you're leaching out the rare earths in one of the processing steps, if you've got lots of calcium, or it's limestone is another word for it, that will neutralise the acid and won't allow you to leach out the rare earths. So the fact that our calcium is so low means that we hope to have very low acid consumption in that leaching step. And you can see for all of those intersections as well that the rare earths are really quite high, well over 1,000 ppm generally. And what we found was that when we sift out the kaolinic material, so the material that we were interested in keeping and selling as a product, that upgraded the rare earth content of that material to 176% of what it had been before. So it significantly upgraded the rare earth content of the sample that we would be treating. So this is the kind of material that we will be targeting to process when we eventually mine this material, extract the kaolin through screening, and then leach out the rare earths from it. So this is the conceptual flow sheet that we are looking at using to process the Caralue Bluff high purity kaolin and rare earth material. So what we do is we mine this very shallow ore body. It has very low overburden and is very easy to dig up and mine because it's a soft clay material. So we dig that up generally with bulldozers and loaders, and we bring that to the processing facility, which is most likely to be on site. That kaolin material is then put into a plunger, and you add water to it, and that creates a slurry out of the kaolinitic material. So that slurry can then be pumped around through pipes. So we pump that through to what we call screens and hydroclones. And the first step is to remove the sand or the quartz material from that, and that leaves the fine kaolin material afterwards. So the leftover from that process is just essentially sand, and we take that material back and we put it back in the pit that we're mining from. So what we've got left is this fine kaolin material that has upgraded rare earths in it. That goes into leaching tanks as a slurry. And then what we do is we add our leaching chemicals to that, be it acid, ammonium sulfate, whatever it is determined from our metallurgy best removes those rare earths from the kaolin. So that is then leached for a set period of time, and then we drain off that leaching solution. That goes to a rare earth element precipitation tank, and we precipitate out the rare earth elements as either oxides or carbonate. So that then becomes a rare earth oxide or carbonate precipitate or concentrate, and then that will get shipped off to a rare earth element separation facility. So that's our first product from this process. Then the second product we have left is the kaolin material, which has now had the rare earths extracted from it. So that then goes through to a dewatering process where it's filter pressed. The water is removed, and then that is generally dried, and that becomes our high purity kaolin product. So we have two potentially saleable products from this process, both high purity kaolin and our rare earth element concentrate. So where do we go here from our Caralue Bluff project? Well, we're now doing variability testing on our metallurgy. So how can we increase those recoveries of the rare earths from the kaolin material? And that test work is currently underway with ANSTO, and we aim to have that back next month, so in November of this year. Pending positive results from that, we'll then start trialling leaching that -45 fraction, which has the improved grades of the rare earths in the kaolin material, and start to see how that improves the kaolin product as well by removing the iron from the system. So coming up towards the end of the year in December, we are aiming to go back and do our resource drilling at Caralue Bluff. So currently we have an exploration target there. We want to go back and upgrade that exploration target to a JORC compliant resource. So we will advance with that. We have our landowner agreements in place to get on the ground and start drilling. Our government approvals are currently in the process of being approved at the moment. I hope to have those before the end of this month, and then start drilling hopefully in November to December this year. That drilling won't take long because it's a quick and efficient process. Hope to have wrapped that up in early next year in January, and then have those drill results back in the first half of next year. And those drill results will then lead back into a resource calculation that hopefully we will again have out before the middle of next year. So yeah, very active time on the Caralue Bluff project. Excited to get our updated and modified metallurgical test work back to see how many of those magnet rare earths we can leach from the kaolin product, and how that then improves the quality of the kaolin material as well, and then get stuck into our drilling program later this year. So thanks for listening, and stay tuned for more exciting developments on the Caralue Bluff Rare Earth and Kaolin project on the Eyre Peninsula. Thanks.